High above us, invisible rivers of water vapor flow through the atmosphere, what scientists call atmospheric rivers. These are not just mere streams of moisture. They are powerful, dynamic systems that play a crucial role in our planet's weather patterns. These colossal corridors transport moisture from the tropics to the poles, shaping our climate as profoundly as ocean currents. They are the unseen architects of weather, influencing precipitation and temperature across vast regions. A single atmospheric river can stretch thousands of kilometers and carry more water than the Amazon River. Imagine a river in the sky, vast and flowing, unseen yet immensely powerful. When these ribbons of moisture hit land, especially mountains, the vapor cools and falls as intense rain or snow. This process is vital for replenishing water supplies and maintaining ecosystems. These events have long nourished forests, filled reservoirs and sustained rivers, making many regions habitable. They are the lifeblood of many ecosystems, supporting diverse forms of life. But as the climate warms, the atmosphere holds more moisture, making these rivers in the sky larger and more intense. This increase in intensity poses new challenges for weather prediction and disaster preparedness. What was once a life-giving phenomenon is now a growing threat, with deluges becoming more extreme. The potential for destruction is rising as these atmospheric rivers unleash their fury. Communities and ecosystems face increasing risks from floods and landslides. The impact on human life and natural habitats can be devastating, requiring urgent attention and action. The balance of nature is shifting, and we're witnessing the immense power of these atmospheric phenomena in a new, often destructive light. The need for understanding and adaptation has never been more critical. Understanding these changes is crucial for our future. Scientists and meteorologists are working tirelessly to predict and mitigate the impacts of these powerful systems. The unseen rivers above us are both a marvel and a warning. They are a testament to the complexity and interconnectedness of Earth's systems. They remind us of the complex forces that make our world habitable and vulnerable. Our planet's delicate balance is at stake, urging us to act responsibly. As these rivers grow, so does our need to adapt. Building resilient infrastructure and community preparedness are essential steps in safeguarding our future. The story of atmospheric rivers is now a story of survival. It is a call to action, a reminder of our shared responsibility to protect and preserve our planet for generations to come. Atmospheric rivers begin their journey in the tropics, where the sun's heat warms the ocean, causing the air above to become saturated with vast amounts of water vapor. This invisible moisture is constantly rising from the sea, forming the building blocks of these powerful weather systems. Large-scale weather patterns, such as shifting high and low-pressure systems, act like invisible highways in the sky, channeling this moisture northward into long, narrow, and fast-moving plumes that can stretch for thousands of kilometers across continents and oceans. When these moisture-laden plumes encounter mountain ranges, the air is forced to rise rapidly. As it ascends, it cools and condenses, releasing torrents of rain or snow in a dramatic process known as orographic lift, which can transform weather in a matter of hours. Scientists track and measure the strength of these atmospheric rivers using a metric called integrated vapor transport. This allows them to rank each event from weak to extreme, much like how hurricanes are categorized, providing crucial data for forecasting. A strong atmospheric river can unleash historic amounts of rainfall in just a few days, overwhelming rivers and causing widespread flooding that can reshape entire landscapes. These events are both vital for replenishing water supplies and reservoirs, but they also pose a major natural hazard, threatening communities and infrastructure with sudden floods. The science behind atmospheric rivers helps meteorologists predict their arrival and potential impact, giving communities valuable time to prepare and respond to these powerful forces of nature. Understanding the mechanics of these celestial waterways is essential for managing both their life-giving benefits and their destructive dangers, ensuring a balance between water security and disaster prevention. The more we study and learn about atmospheric rivers, the better equipped we are to protect ourselves, our homes, and our future from their unpredictable power. Europe's Atlantic-facing coasts are prime targets for atmospheric rivers, steered by prevailing westerly winds. When these moisture-laden systems hit mountain ranges like the Alps or Scottish Highlands, they unleash intense rainfall and snow. Coastal and mountainous regions are especially prone to flash floods and landslides. Major river valleys, such as the Rhine and Danube, can quickly become overwhelmed, spreading floods far downstream. A single atmospheric river can trigger flooding across multiple countries. Europe's geography and weather patterns make it uniquely vulnerable to these powerful events. History is filled with devastating storms powered by atmospheric rivers, even if they weren't called that at the time. The 1953 North Sea flood, fueled by a powerful atmospheric river, breached defenses in the UK and Netherlands, killing thousands. Centuries earlier, the Grote Mandrenke storm tide drowned entire towns along the North Sea. These events show how atmospheric rivers can combine with tides and winds to create catastrophe. Studying these disasters helps us understand the risks we face today. Extreme weather is not new, but its frequency and intensity are increasing. The past offers vital lessons for our future. The echoes of these storms are warnings written into Europe's landscape. In December 2015, Storm Desmond brought a modern example of an extreme atmospheric river to the UK, unleashing a weather event that would be remembered for years to come. A vast plume of moisture, traveling thousands of miles from the warm Caribbean, unleashed record-breaking rainfall over northern England, drenching the landscape in relentless downpours. Cumbria saw over 340 millimeters of rain in just 24 hours, an astonishing amount that overwhelmed rivers, burst their banks, and sent torrents of water rushing through towns and villages. Thousands of people lost their homes and businesses. Vital infrastructure, including roads and bridges, was devastated, leaving communities cut off and in shock. In the aftermath, communities rallied together, distributing sandbags and helping neighbors, but the economic and emotional toll was immense, with many left to rebuild their lives from scratch. Scientists studied Desmond in detail, confirming the direct link between the atmospheric river and the deluge, and warning that such events are becoming more frequent. Climate change made such an event far more likely, as warmer air holds more moisture, fueling heavier and more intense rainfall than in the past. Storm Desmond is a glimpse of Europe's future if global warming continues unchecked, a warning sign of what may lie ahead for many regions. These devastating events are no longer rare. They're becoming the new normal, with back-to-back storms and repeated flooding now a regular threat across Europe. The lesson is clear. We must adapt to a wetter, more volatile climate, investing in stronger flood defenses and smarter planning to protect our communities. The stakes are rising with every storm, and our response will shape the future for generations to come. For every degree Celsius the planet warms, the atmosphere can hold 7% more water vapor. This means atmospheric rivers are becoming wetter and more intense. Recent data shows these storms already carry more moisture than in the past. Europe faces more frequent and severe floods, especially in winter. The definition of a 100-year flood is changing. These events may soon happen every few decades. Our infrastructure and emergency services will be tested as never before. The landscape itself may change, with more landslides and shifting rivers. We must prepare for a future where the sky brings more water than ever before. Atmospheric rivers aren't just destructive. They're essential for replenishing water supplies and snowpacks. In drought-prone regions, they can mean the difference between scarcity and abundance. The snow they deposit feeds Europe's great rivers, supporting agriculture and industry. But the same force that brings life can also bring disaster if a storm stalls or intensifies. The line between benefit and catastrophe is razor thin. As the climate changes, this balance is shifting toward greater risk. We must find ways to harness the benefits while managing the dangers. Living with atmospheric rivers means respecting their power and unpredictability. To face stronger atmospheric rivers, Europe must adapt and build resilience. Improved forecasting, using satellites and advanced models, gives earlier warnings and saves lives. Infrastructure must be upgraded, and nature-based solutions, like restoring floodplains and planting trees, can help absorb excess water. Community preparedness is vital. Clear evacuation plans and public education save lives. True resilience means informed, prepared communities, not just higher flood walls. Ultimately, tackling climate change is the most profound adaptation. Reducing emissions limits the risk of ever more extreme storms. Our actions now will shape the balance between the benefits and dangers of these rivers in the sky. Atmospheric rivers are a breathtaking part of Earth's natural rhythm, moving water from oceans to land. But human activity is altering this ancient cycle, making storms more intense and unpredictable. The floods and landslides we see are symptoms of a planet out of balance. Understanding atmospheric rivers is everyone's responsibility, not just scientists. Knowledge empowers us to prepare, adapt, and demand change. The natural world still has the power to surprise and to warn us. As we look to the future, respect for these forces is essential. We must listen to the planet's warnings and act wisely. The health of our world and our safety depend on it. The rivers in the sky are both a marvel and a call to action.